I said earlier that there's two kinds of multiplication. There's the dot product, and then there's the cross product. So far we've only been doing the dot product, so I'm going to show us why we do the cross product, and then I'll show you how to do it. So let's say we have two three-dimensional vectors, u and v. So this is supposed to be kind of like a 3D picture, so imagine those on a plane. There are many times when you want to figure out what the vector is that's 90 degrees to both. And so if you have u and v, we want to know what that vector is. We want to know what the one that is both 90 degree to both would be. So that is where we cross product. So for example, I'm going to take a 0, -1, 3, and I'm going to cross it with b, 2, 0, -1. And just because of the notation, the best way to do this is to turn these into our engineering vectors. So I'll write it here. A would be 0i. Now, we wouldn't really have to write that, but I'm doing it just so we don't get mixed up here. -1j, and then the last one would be 3k. So k would be our third one when we're doing three-dimensional vectors. Alright, for b, it would be 2i plus 0j. Again, we wouldn't have to write 0j, but just for clarity, I'm gonna. And then we'd write -1k. Now, I'll write a cross with b right here. It's a symbol. Now here's how you're going to do it. Now on the first row you're going to write a, so that'd be 0, -1, 3. I'm just taking the numbers. The second row I'm going to put 2, 0, -1. And the best way to do this is to rewrite the first two rows again. So I put I and j over there, and I just write those numbers again. Now this is called, I think it's called the basket weave way to do this. There are a couple ways to cross product, but this is my favorite. So what you're going to do is you're going to multiply this way, go back and subtract that. So what happens here is that -1 times -1, let me write that out, and then I'm going to subtract 0 times 3. And that's going to be my I part. Okay? So for the next one we do the j cross. So that'd be 3 times 2. And we subtract up. So that'd be subtract -1 times 0. And that would be the j part. Same with the last one. K is going to cross like that. So k is 0 times 0 minus 2 times -1. Okay. So when we figure this out, that would be 1 minus 0. This would be 6 minus 0. And this would be 0 minus -2. So this is going to be +2. So our cross product is going to be another vector, 1, 6, 2. Now if we check this out, if we want to make sure that that is really the cross product, what we can do is we can dot it with these two. And when we dot it, it should be 0 because this should be orthogonal to both of these. So if I check 6 times -1, that'd be -6. 2 times 3, that would be +6. We're done. A works. How about B? 1 times 2 is 2. 6 times 0 is 0. 2 times -1 is -2. Again, it would cancel out. So I do know this is my cross product. It's my orthogonal vector to both.